Good morning, guys. I decided to pre-record this lesson for you. I'm still in Slovakia, but for the next week, since I'm going to travel to Holland and I should stay a few days there for isolation and for another testing and whatever. So I'm not sure what kind of internet and what kind of connection I'll have. That's why I'm pre-recording this lesson for you. We will start today chapter 3, just the basic introduction. It's going to be about the further complex numbers. And this chapter is going to build on something that you already learned in FP1, but obviously goes deeper. As you know, complex number is a number that can be expressed in the form x plus yi or a plus bi, where x and y are real numbers. And this is the real part, and this is the imaginary part. But we call this form of the complex number Cartesian form. Cartesian form of a complex number. But we have two another forms. One is called Modulus-Argument form. It's this one, plus y sine theta. And there is one more form for now that is called exponential form, and that has this form. So this one is called Modulus-Argument form that we're gonna talk about first. Modulus-Argument form, and this one is exponential form. Exponential form. Okay, so we're gonna do this, and then we're going to have exponential form as well. So we will start with the Modulus-Argument form. So Modulus-Argument form of the complex number has this form where r is the positive real number, It's called modulus. You know it represents the distance from zero. Or from origin. So r is x squared plus y squared, or a squared plus b squared if it's in that form. And theta is the angle called argument. That's also you know. And you also know it should be between minus pi and pi. It's called principal argument. If it's in this interval, or argument if it has another value. Argument, or principal argument, or basic argument. So when you look at the graph, if this is x and this is yi, then this would be the theta, and this is your r. Okay, so then this is z. So z can be written as x plus yi, or it can be written as z equals r times cosine theta plus I sine theta. Now, example number 1. Let me see, for the pure math 2, that's this one. So, if you are given the Cartesian form, then we have, you can always, I do recommend to sketch it on the graph. So when you have minus root of 3 and 1i, so this would be the z. And remember, when you sketch the graph, then you should not be, you eliminate the options of making the mistake. This is your theta, this is your argument, while this is, you can call it alpha, let's say. So it's easy to find alpha because you can use tangent or so tangent alpha. Tangent alpha is opposite side is 1 over root of 3. Remember, it's the size, is the length of the side. Okay, so then alpha, this is the same as root of 3 over 3. And back from the values of the table, you know that is arctangent root of 3 over 3. So alpha is equals pi over 6 or 30 degrees. And that will tell you the argument is then 5 pi over 6, because it's pi minus pi over 6, obviously. Okay, so then you would have the argument. And to find the modulus is even easier, because r is root of x squared plus y squared. What is root of, let me see here, it's negative root of 3 squared plus 1 squared. What is 3 plus 1? Root of 4. What is 2? And then you have everything. You can make the conclusion. So z is 2 times cosine 5 pi over 6 plus I sine 5 pi over 6. Okay, so you have it. So the whole section, what we're going to do today, is about converting between different forms of the complex number. Let's look at the second example. Oops. Obviously, you can pause the video if you're running a little late or you need more time. So the same story here. We have to express, again, as I told you, always sketch the picture. If you do sketch the picture, it's impossible that, or it's unlikely that you would do some mistake, because then I have this. Remember, the argument should be between minus pi and pi. That means I have to go this way. And again, I can find, I'm going to call this beta, this angle. So I can find the argument first. What is 1 squared plus 1 squared? Root of 2. And then when you look at the argument, so tangent beta is 1 over 1. 1 over 1, and then you know that beta is arctangent of 1. What would be pi over 4? So if beta is pi over 4, that tells you that theta is minus pi plus pi over 4. What means theta is minus 3 pi over 4. This is theta, yeah, I forgot there. So theta is minus pi and r is root of 2. So then again, you can make the conclusion that z can be expressed as root of 2 times cosine minus 3 pi over 4 plus I sine minus 3 pi over 4. And that's done. You can at times use the property of cosine. You know that cosine is even function. So you know cosine negative theta is cosine theta. Cosine theta is even function. And the second one is sine negative theta is negative sine theta. What would be sine theta is odd function. Okay, so we can use this a little later as well. I could rewrite this too. So let's look at the next example. Example 3, I think that's this one. So now I have a different form there. I do encourage you before we will start this question, how to get this form. That's also quite interesting, because you can have a look. You don't have to, but if you are interested in math, you can have a look. You can have a look on page 20 how to prove that e to power of I theta is equals cosine theta plus I sine theta. This is interesting, but you don't have to know the proof, okay? So I'm not gonna do the proof. If you are interested, then look at page 20, all right? But because of this, I know that z equals r times cosine theta plus I sine theta. This can be replaced by e to power of I theta. So that means I'm going to get my new form. That's the exponential form. Please know the names e, I, theta. Okay, so this is my exponential form. Exponential form of complex number. Of a complex number. Right? So again, the same story. Just ask yourself, after sketching the picture, it's 2 and minus 3, 2, 1, 2, 3. So that's here. When you sketch, that's this here, that's theta. So what do I need to write this form of such complex number? Again, you need r. R would be root of x squared plus y squared. What would be root of 2 squared plus 3 squared, or minus 3 squared, but that's the same. So root of 13, if I'm not mistaken, root of 13. And for the theta, what's the theta? So I know that tangent theta, when you look at the triangle, this is 3, this is 2, so it's 3 over 2. So theta is arctangent arctangent of 3 over 2. So when you do this on the calculator, you will get let me see, 0.98. Okay, but remember, I'm moving. Maybe I should call this theta 1, and then you know that theta is negative 0.98 because I'm moving this direction is negative and this direction is positive. So clockwise is negative and anti-clockwise is positive. Right? So then you have it, and then you can write z equals r is root of 13 times e to power of I negative 0.98. Root of 13 e negative 0.98 times I. Good. Let's try to do one question from the next example. Example 4, that should be this one. Let's do only B case because that's more interesting. The A case is basically similar. Again, we need to now convert between the Modulus-Argument form into exponential form. So that's even easier, yeah, because, well, I'll do both. A, so r is root of 2, that's given. Theta is pi over 10. So what that means is z equals root of 2 times e to power of I pi over 10. But in the B case, that's more interesting because the given number or the given form has minus in between, minus I sine pi over 8. And in order to apply, I need to have plus here. But that's quite easy because what I told you before, sine theta or sine minus theta is minus sine theta. And this is what you have here, minus sine theta. So that means this could be written as minus sine theta can be written as plus I sine negative pi over 8. And also here cosine negative pi over 8. Okay, and 5 doesn't change. So in that case, then it's easy because this is your r and this is your theta. So I can make the conclusion that z is equals 5 times e to power of minus pi over 8 times I. So the trick here is this sign. Be careful. That must be plus there if you want to convert it. Must be plus. Okay? So, because I know that sine minus pi over 8 is minus sine pi over 8. So minus sine pi over 8 will give me then plus. Good. Next example should be this, example 5. Similar story, just pay attention to, okay, this way I'm going from exponential form to Cartesian form. Exponential to Cartesian form. So for the Cartesian form, I need x and y. So in this case, I have r equals 2 and theta is 3 pi over 4. So when you sketch it, 3 pi over 4, that's 135 degrees. That's this one. 3 pi over 4. That means this will be pi over 4 and this is root of 2. Okay, so basically I just need to figure it out. What is this and what is this? What is x and what is y? But that's easy because it tells me you can use sine, cosine, whichever, or tangent, up to you. I know that sine pi over 4 would be y over root of 2. And I know sine pi over 4 is root of 2 over 2, y over root of 2. So y is obviously 1. Or because it's 45 degrees, it must be 1. And then the same story is for the cosine. Cosine pi over 4 is x over root of 2, but that's again root of 2 over 2. But in here you have to be careful because in here you get x equals 1, but I am on the left side of 0, right? So the conclusion would be minus 1 plus 1i. Minus 1 because I'm on the left side of 0 here, right? Example 6. Example 6 is here, I guess. Similar story, except this way. In this case, I'm going from exponential form, exponential to Modulus-Argument. Modulus-Argument. In this case, it's easier. Modulus-Argument. Just pay attention to this condition because in here I have r is equals to 2 and the argument is 23 pi over 5. But 23 pi over 5 is about the pi. Yeah. So if you want to convert it, just 23 pi over 5, just subtract minus 2 pi, subtract minus 2 pi, and when you subtract minus 2 pi, you should get, and you will get 13 pi over 5, but it's still over 1 pi. So go again, 13 pi over 5 minus 2 pi would be 3 pi over 5. And now it satisfies this condition, so this is okay now. And then you have it. You can just write the conclusion. Z equals 2 times cosine 3 pi over 5 plus I sine 3 pi over 5. Okay, the last example that is solved also in the book, and then we will practice some together, and then I'll give you some exercises to practice on your own. We need to prove that if this is given, this is known, then I have to prove that cosine is equals to this. So what I can do is to use the even and odd function properties, because I know that this is the same as this, and that's why this is the same as cosine negative theta plus I sine negative theta. But I also know that e to power of I theta is equals cosine theta plus I sine theta. And now I can, what can I do? I can add them. If you add these two, this one and this one, well, actually, before adding, you know that this can be written as cosine theta minus I sine theta. And then I'm going to add this and this together. So when you do so, you will get minus I theta, e to power of minus I theta plus e to power of I theta is 2 times cosine theta. So cosine theta is equals e to power of I theta plus e to power of minus I theta over 2. And this is what you needed to show. So this is fine. Q, E, D. So what I'm going to do now, we will practice, I will practice few questions only with you, just quickly, and then you can check OneNote and you will find the ones that you need to do. If you do not need more practice with me, then it's okay, you can stop, you can pause the lesson, stop the video and do just your own and check. It's up to you, okay? So I'm doing these ones for the guys who need more guidance if you do. Let me see this one. So this is taken from page 23 and set 3a. Okay, so a case, again, just check. I need to go to Modulus-Argument form. So when I sketch, this is the 7. So z can be expressed as 7 plus 0i. So obviously r is 7 and theta is 0 degrees or 0 radians. And that's why z equals 7 cosine 0 plus I sine 0. Oops, sorry, 0. And that's it. B case, minus 5i is here, minus 5i. I need this angle, what is minus pi over 2, that is okay in the principal argument. And then r is obviously, r is 5, because it's 5 units away from the origin. R is 5, theta is minus pi over 2. So my number is z 5 cosine minus pi over 2 plus I sine minus pi over 2. And C case, I have sketch it. It would be in the first quadrant. So I need to find this angle and I need to find the R. So R equals root of 3 squared plus 1 squared, what is 2, and tangent, I'm gonna call it theta. Tangent theta is root of 3 over 1. So then we know from our table is 60 degrees or pi over 3. And then z equals 2 times cosine pi over 3 plus I sine pi over 3. Okay, and then the last one, minus 8 plus 6. Minus 8 plus 6. Minus 8 plus 6. Minus 8 plus 6i. Hops, minus 8 is here. 6i is here. So I am looking for this angle. But first I will find out, I'm going to call it alpha. So tangent alpha is 6 over 8. Tangent alpha is 6 over 8, what is 3 over 4. And then, oh, this is not D, my bad. A, B, C, H. This is H. H. So tangent is 3 over 4. So from there, you can obviously use the calculator because there's not one of the basic values. What should be 2.5 roughly? Well, this is not 2.5. The total is 2.5. Let me see. I don't have a calculator here. Whatever this is, okay. And then the theta is pi minus alpha, and that will be 2.5 to 2 decimal places. And then R is root of 8 minus 8 squared plus 6 squared. What is 100? Root of 100 is 10. So finally Z is 10 cosine 2.5 radians plus I sine 2.5 radians. Next example, I think maybe this one, I'm not sure now. No. Delete. This one. I will do 2 questions from here. Question E. Again, I want to express it in the Cartesian form. That's one of the easiest because all you need to know are the basic values from the table I was trying to teach you back in FP1. I'm going to check if you know it when I'll come back. So I have Z equals 2 root of 2 cosine, well, I'll figure it out straight away. Cosine pi over 4 is root of 2 over 2, but I am in the 4th quadrant. All students take calculus. What is positive? So root of 2 over 2 plus I and sine minus pi over 4 is minus root of 2 over 2. And just simplify it. When I do simplify it, then it's get 4 over 2. It's 2 minus 2i. Okay, this is 2e. And then f, basically you just figure it out the values. Z is minus 4 times. And again, find out cosine 7 pi over 6 and sine 7 pi over 6. So cosine 7 pi over 6 is the same as 7 pi over 6, that's 210 degrees. 210 degrees, that's the same as 30. That's negative root of 3 over 2. Yes, and plus I sine 210 degrees is 1/2. And then simplify it. This would give you positive 2, so 2 root of 3 plus, wait, there is a minus, sorry, minus here. There should be minus half. Here should be minus half because I'm in the third quadrant. And then you will have plus 2i. Good. Next one. Next one is this one, number 3. I'll do 2 examples from here. Again, double check. I want this from whatever the form is given. Well, E case is Z is 2 minus 5i. 2 minus 5i. For that I need what is the r and what is the theta. Yeah, so you can figure it out. Again, picture can help you. 2 and minus 5i, that's this. I want this angle. This is E, so I want this one. So theta 1 is arctangent 2 over 5. 5 over 2 opposite. Yeah, 5 over 2, my bad. 5 over 2. And then you can find on the calculator, this should be 1.19, I think. So theta is minus 1.19. If you radians. If you find some mistake, then please tell me, but it should be fine. And then radius is root of 2 squared plus minus 5 squared, 25 root of 29. Okay, that can be simplified. So then Z equals root of 29 cosine minus 1.19. Oh, sorry, I'm expressing in the, my bad, in the exponential form. So e to power of I and minus 1.19 or 1.99 I. Good. And then H case, I want radius and I want angle, but that's for dummies because it's given. Radius is 8. Not radius, sorry, modulus, my bad. And be careful here with the theta. You can't say that theta is pi over 6. This would be wrong. Okay, this would be wrong because of this minus here. There must be plus, so you have to use the same trick as I showed you in the example above. So this Z, 8 times cosine pi over 6 minus I sine pi over 6. First, use that trick I showed you with the cosine, with the even and odd function. Plus I sine minus pi over 6. So this is your modulus and this is your theta. So you can then find out Z is 8 times e to power of I minus pi over 6 or minus pi over 6i. That should be it. Then I think I have 2 more questions. That's no, wait, which one was this? This one. Question 4. We will do B case. B case expressed following in the Cartesian form. So Z is 4 times e to the power of pi I. So r is 4 and theta is pi. And well, then it's easy because this is 4 times cosine pi plus I sine pi. But you know that sine pi is 0, this is 0, and cosine pi is -1, so this should be -4. This is B case, and then we have, what is this, F case. F case is r equals e to the power of, so 1 times e to the power of 5 pi over 6i. Again, r is 1 and theta is 5 pi over 6. So you can write it as 1 times cosine 5 pi over 6 plus I sine 5 pi over 6. And using the values in your head, or if you still didn't learn it, then you can use a calculator. Then cosine pi over 6 is minus root of 3 over 2, and sine 5 pi over 6 is 1/2, because it's 1/2 I. And that's it. And I think the last question is question 5. That is this one. And I will do the A case, express the following. So I'm going the same way, I just need r and I need theta. So in here, r is equals to 1 and theta equals 16 over 13 pi. But just be careful here because pi must be between minus pi and pi. So in this case, what you can do is z equals 1 times. First you can write it, cosine 16 13 pi plus I sine 16 over 13 pi, but it has to satisfy this condition. So 16 over 13 pi, just try to subtract 2 pi minus 2 pi. So it would be minus 26, so it would be minus 10 over 13 pi. Minus 10 over pi, so you can write z is equals cosine minus 10 over 13 pi plus I sine minus 10 over 13 pi. Okay, so I stop here, then please go to OneNote, and you will find in the homework section that you can still do in the lesson. OneNote homework section FP2. FP2, the same where you found the link.